So as a complement to the previous video, I'm now simultaneously showing the locus of x2, x3, x4, and x5 in light brown, red, light blue, and green as I vary the center of the circular caustic for a family of blue triangles, which are Poncelet inscribed in an outer ellipse and circumscribing a circle. So I'm just varying, see the center of the caustic and observing what's happening to these loci. Specifically, these four loci, or these four triangle centers, they lie on this line called the Euler line of a triangle, right? And you can see that they are all, the loci are all ellipses, okay? And they have the following properties. x2 is always a homothetic copy of the outer ellipse. x4 is always a homothetic copy of the outer ellipse rotated 90 degrees, that cyan locus up there, right? x3 has a property of always having its major axis pointed at C. And there's a region, which we haven't derived yet, of positions of C, which C is interior to the locus of x3. Okay, so what is this region? That's an exercise. What's the region? What's the boundary of the region for C such that C is interior to x3? Even when C is interior, the major axis of x3, this red curve, will contain C. Okay, now x5 has this additional property, which we mentioned in the previous video. You can see here that x5 is the midpoint between x4 and x3 on the Euler line, this dashed gray line. x5 describes an ellipse with one focus on C. So we thought this was pretty cool as well. Okay, now what I want to show in this video, if GeoGebra will allow me to do this, is I want to place C on the major axis of the outer ellipse, okay, and now study the dynamic loci of x2, x3, x4, and x5. Now we mentioned this in the previous video that there's two positions for C. There's two positions for C where the locus of x4 shrinks to a point that coincides with one of the foci of the outer ellipse. So F2 here, and if I move C to the other side, you get the symmetric situation where you get x4 right here on the other focus. So let's go back to this this situation here. Okay, assume that x4 is stuck. Now you see two other phenomena here. Okay, you see two other phenomena. First of all, yeah, it's gonna be hard to do this by hand like that. Okay, first of all, x5 still contains one of the foci of x5 is still C. Okay, now look at what's happening to x3. x3, whose major axis will contain C, seems to have a focus on the center of the outer ellipse. How cool is that? Right, so this is the center of the system, and I'm eyeballing at one of its foci now, when x4 is out here and has shrunk to a point, is the center of the outer ellipse. Any other phenomena here? It could be that the other focus of x3 is the vertex of x5. Right, just eyeballing this, it looks like the vertex of the green curve is the other focus of x3. Okay, and it looks like x2 is centered in some special place over here as well. So what I just wanted to say on this video is that when you place C on the special location where x4 shrinks to a point, a couple other observations are in order, right? So regarding one of the foci of x3 and perhaps the center of x2. Okay, so that's what I have for now. This is just giving us sort of a simultaneous idea of what's going on. Another investigation is what are the intersections between these foci of these loci, and there could be some interesting structure in their intersection. I'm going to leave a link in the description to GeoGebra, okay, so you can experiment with these phenomena. See you on the next video.